So welcome to all once again. So we are going to start our meeting. Is there any problem in the content which I have delivered yesterday? Okay, no problem. Then we should start with the new terminology related to the circuit theory. Just for your revision, I would like to highlight that yesterday we have talked about the some more terms which include the passive elements, the active elements, then the different type of sources, then we have also discussed about the independent sources, then dependent sources, type of dependent sources. I have already elaborated. There are four dependent sources are there, and now they will be frequently coming in your numericals. Then what is the electrical circuit or network? Then on the basis of the direction of current, we have again classified active source, passive source. If an active energy source is present, then it is called an active source element or active network. Passive network which have only passive components. Then we have also talked about bilateral, unilateral elements and what are the corresponding network. Okay. Then we have talked about distributed network, lumped network. Then we have stopped here where we were talking about the linearity and the non-linearity. Okay. So again, I would like to highlight that just as we have active element, passive element, unilateral element, bilateral element, we have a linear element and a non-linear element. Okay. And accordingly, we have a linear network and a non-linear network. So let us understand what a linear network is. So this is a very important definition, mind it. Don't take it easy because it will be used as and when, and it will be asked in your viva voce and other interview exams also, that what a linear element is. Okay, and what is a linear network? Okay, so first of all, what linear element is? If a element obeys the principle of superposition. Okay, so mind it, here we are concerned with the principle of superposition. Okay, so any element which obeys the principle of superposition is said to be a linear element, and the same is true for the network. If any network obeys the principle of superposition, then it is termed as a linear network. Now you will definitely ask what a linear network is. So you will definitely ask what is superposition principle. Okay, so superposition can be defined to have two simpler properties. Mind it, superposition principle contains two properties. Now if any element or if any network obeys these two properties successfully, okay, then we say that yes, the given element or given network obeys the principle of superposition, hence it is a linear network. Both properties should be satisfied. Mind it, not one property. Is it clear? Generally student make commit mistakes that they simply verify one property and say it is linear. Okay, no, in order to call an element to be linear, okay, to obey the principle of superposition, it should obey the principle of additivity, it should obey the principle of homogeneity. Okay, so it is very clear that both additivity and homogeneity principles are to be obeyed in order that the element may be called as obeying the principle of superposition principle. So let us now discuss additivity. Okay, now to understand the additivity, mathematically we define additivity that uh, if if an element is there, and now to understand, let us take I will draw some diagram. Okay, so that you can grasp the fundamental easily. Okay, so let us take so let us take, suppose this is your any element. Okay, now you apply an input to an element. Okay, Okay, on this side, you apply an input element. Okay. Okay, and on this side, you are taking the corresponding output. I am simply writing out. Okay, so now uh, what you can do, what this element can have, this element will have a certain input, and it will, for that input it will give a output. Now to understand, let's take a resistor. Now you apply voltage to a resistor, so what will be your output? Output will be definitely current. Okay, now suppose the input is x1. Okay, input is x1, and the corresponding output for that input is, say, y1. It is clear. Now I am again applying another input x2. Okay, and let's say its output is y2. So now what you get, that I have to understand in terms of resistor, let I have applied a voltage V1 and getting a corresponding current I1. Second time I am repeating and I am doing another experiment on same resistor. I am applying a voltage V2 and getting an output I2. Clear? Okay. Now at the additivity principles state that the given element or given system obeys the principle of additivity if I apply an input equal to x1 plus x2. Previously I have applied x1 and x2 independently. Now I am applying x1 plus x2. That is, I am adding these two input signal. That is, in terms of resistor example, I am applying a voltage which in magnitude equal to V1 plus V2. And if I am getting an output equal to y1 plus y2, then I say my system obeys the principle of additivity, not superposition. Still it is incomplete, it is a partial. Okay, so I am applying x1 getting y1 input, I am applying y1 output, I am applying x2 input getting y2 output, and if I am now applying an input equal to x1 plus x2 and I am getting an output equal to y1 plus y2, then I can say my system obeys the principle of additivity. In other words, in mathematical it is being written as f x1 plus x2 is equal to fx1 plus fx2. So this is the principle of additivity. Once again I repeat you that in terms of resistor, if I applied a voltage V1 getting current I1, then again applying V2 getting current I2. Okay, and if I now apply a voltage equal to V1 plus V2 and I get a current equal to I1 plus I2, then I can say my system obeys the principle of additivity. Okay, still I can't say whether it is a linear element or non-linear. I can simply say that if my system is verifying this principle, this law, then I will say yes, it obeys the principle of additivity. Now what is the principle of homogeneity? So again, to understand this homogeneity principle, let us take this system only. Okay, now again this system has an input and a corresponding output. Let say your input is x1. Okay, and your corresponding output for this input is y1. Okay, now I increase the strength of this signal. I can increase or decrease by a certain constant value, say k time. I have increased the input in the second experiment. I have increased the input equal to kx1, where k1 is any constant term. Okay, and if I am getting an output equal to k y1. Okay, so to understand in terms of resistor, I have applied a voltage V and getting a current I. Now I am increasing the voltage by k times, that is kV, and if I am getting the current ki, okay, then I say that my system is obeying the principle of homogeneity. Okay, in order to understand in a numerical way, suppose I have applied a 10 volt to a resistor and getting a 5 ampere current. Now I increase the voltage 2 times, that is, now I am applying a 20 volt and getting a current equal to 10 ampere, that is 2 times the previous current, then I say that my resistor is obeying the principle of homogeneity. Okay, and the element or the network which obeys both the principle of additivity and homogeneity, then I will say that yes, my system is a linear element or linear network or linear device, and it obeys the principle of superposition. I think so. It is clear. If not, you can write down in the chat box. Please write something in the chat box so that I come to know that yes, my viewers are yes, somebody has said that yes, man, yes, okay, fine, clear, okay, it is clear, fine, nice, no doubt. So it is very clear that in order to verify a system to be called as a linear, okay, it should obey the principle of superposition. That is, it should obey two laws, additivity and homogeneity, both laws. Okay, so let us take an example. Okay, I will give you an example. Say function y is equal to 3x plus 2. So write in the chat box y is equal to 3x plus 2. Given system is there. Okay. Is it a linear system or a non-linear? Tell me fast. Okay, Hardik Singh is saying non-linear. Anybody more? So if you have really understand, then please give me the answer fast. It is a linear or non-linear? Garvesh Chittoda is saying non-linear. Very good. Anybody more? Dhananjay Paliwal, non-linear. Very good. Keshav Sharma, non-linear. Tanisha Kothari, non-linear. Very good. So most of the people, most of the students has said that it is a non-linear. It is very correct. Okay. Though it is an equation of a linear equation. If you have learned in your coordinate geometry, you must be knowing that this equation is representing a straight line equation. Okay. It is like this. Okay. I think so. It is representing this line. Probably. It is like this type of line. Okay. But though it is a linear line, but it is a non-linear system. It is representing a non-linear system. How you can verify it? Suppose those who haven't understand, please go through the mathematics behind how to verify it. I apply an input x1 and get an output y1. So y1 is equal to c 3x1 plus 2. Am I correct? Now I am applying another input x2 and getting a output y2. Okay, so y2 is equal to nothing but what I get, 3x2 plus 2. So this is clear. I have applied x1 and x2 separately and got the corresponding response y1 and y2. Now to this system I apply input is equal to x1 plus x2. So what should I will get y? So let the y be y3. Okay, so y3 is nothing but what you will get, 3 just sorry what you will get, 3 bracket x1 plus x2 plus 2. Now you open this, you will get y3 is equal to 3x1 plus 3x2 plus 2. Is it equal to y1 plus y2? No, it is not equal to y1 plus y2, because if you combine y1 and y2, you will get 3x1 plus 3x2 plus 4. Mind it, but here y3 is coming to be plus 2 only. Hence, y3 is not equal to y1 plus y2. Hence, it does not obey the principle of additivity. Hence, it is a non-linear system. Though your mathematics say that it is representing a linear straight line, but it is not a linear system. It is not representing a linear device. It is not representing a linear system. Is it clear or not? Okay, now you can verify. So one principle failed means you cannot say that it is obeying the principle of superposition. Okay, it should obey both the laws, that is additivity principle and homogeneity principle. Okay, in this case you may see that let us check the homogeneity principle also. So y is equal to 3x plus 2. Okay, let us, this is equation. Now I increase by x by 3 times. Okay, so what I will get, when I place x is equal to 3x, I will get 9x plus 2. Okay, so is the 9x plus 2 is 3 times of 3x plus 2? No, it is not there. So again, it is not obeying the principle of homogeneity. So both additivity and homogeneity principles are not being followed. But mind it, if when any of the principle fails, any of the law fails, then we say it is not a linear element. It is very clear. So from now onwards, so on this basis, okay, so on this basis, can you tell me what about your so-called so on this basis, can you tell me what you will say about your register? Okay, so what you will say about your register? Give your answer in the chat box. Is register a linear element or a non-linear element? Yes. So I am waiting for your response till I am drawing a register. Okay. So do tell me whether yes, register is a linear or a non-linear. Hardik Singh saying is linear element. Okay. Anybody else? Mayank Pawar non-linear. Very good. Anybody more? Lakshman Singh non-linear element. So this is a register is there. Okay. Okay. Yogesh Sharma is saying linear. Very good. Bharulal Dadi, it's linear. Alkit Vijay, linear. Okay, so somebody are saying linear, somebody are saying non-linear. The correct answer is register which you are using in our analysis purpose, we assume it to be a linear. How? Because the resistor is nothing but a conducting material. Okay, and for conductor, we have a very good law. V is equal to Ri. You all must be knowing this law. Okay, this is nothing but your so-called Ohm's law. Okay, so now you what you have to do, you have to just verify it whether it is obeying the principle of whether it is obeying the principle of linearity and linearity or not. That is, it is obeying the principle of additivity and homogeneity or. Okay, let us verify. Suppose I place voltage, suppose I have a current I1 corresponding to V1. Okay, so I will get first equation, V1 is equal to R I1. Okay, and let I apply another voltage V2 and corresponding current is therefore R I2. Okay. Okay, don't get them. This is I2 only. Okay. Now I apply a current equal to I1 plus I2. Okay. So let the voltage is V3 for this current. Okay. So what I will get, R is equal to I1 plus I2. When I expand this, what I will get, everybody knows it. You all are smart enough in mathematics. So very simple mathematics. When I expand it, what I will get? Ri1, okay, Ri1 plus Ri2. Very good. Everybody will agree with me. That is, I will get Ri2. Now you compare. What is Ri1? Ri1 is nothing but V1. And what is Ri2? It is nothing but V2. So what I will get ultimately? V3 is equal to, okay, nothing but your V1 plus V2. It is very clear. So we are getting V3 is equal to V1 plus V2. That is very clear. Is there any problem so far? No. Okay. So resistor from now onwards will be considered as an linear element. Now let us take another example. Okay. So let us take another example of inductor. We have the three basic elements: resistor, inductor, and capacitor. They are also being termed as an Brahma, Vishnu, Mahesh of our electrical engineering. Okay, so we have talked about the resistor. It is okay. One more thing, it obeys the principle of homogeneity also. Okay, though I have verified only additivity, but let me clear myself that it obeys the principle of homogeneity. You can easily verify it. Let's comes to the another element, that is your inductor. So from your side, first of all, answer should come. Inductor, an ideal inductor, mind it, I am talking about the ideal inductor. Ideal inductor means which have only inductance L only, inductance L Henry, but no resistance, no capacitance. When I say ideal resistor, means it have only resistance. Ideal means adarsh. In Hindi, the meaning of ideal is adarsh. Okay, so ideal resistor means no capacitance, no inductance. Ideal inductor means no capacitance, no resistance. Ideal capacitor means no inductance, no resistance, only capacitance. So let us talk about the so what you people will say. Uh, what is this so called linear element? As Garvesh Chittoda is saying, V is equal to L di by dt. Okay, fine. Anybody more? Okay, so I am drawing an inductor. Okay, that's how inductor is look like. Okay, this is an inductor. Okay, linear. Prem Prakash Singh is saying linear. Alkit Vijay is saying linear. Okay, let us verify it. Most of them people are saying linear. The equation of an inductor, which you have learned in your lower classes, is like this. V is equal to L di by dt. Okay. Now, let us apply current I1. So I will get a voltage V1. V1 is equal to, okay, L d I1 by, oh sorry, the problem is there. So we get V1 is equal to L1 d I1 by d2 dt. Okay, and I am applying another current, okay, and getting a voltage across the inductor. V2 is equal to L, this is L, not L1, L d I2 by dt. Okay, now I apply a current equal to I1 plus I2 to this inductor and getting a voltage V3. Okay, so this V3 will become L D bracket I1 plus I2 upon dt. So now you open this bracket. You know that the differentiation from differentiation knowledge, you know that it obeys the principle of additivity. Okay, so I can open this. So what I will get, V3 is equal to how much? L d I1 by dt. Sorry, and plus again I will get the second term as L d I2 by dt. Okay. So what is L d1I by dt? d1I by L d1I by, it is nothing but V1. See this equation. What is L di2 by dt is nothing but V2. So what I will get from here, that V3 is equal to nothing but V1 plus V2. So the inductor is obeying the principle of additivity. Okay. Now let's talk about the homogeneity principle. Okay. Now we have this equation V is equal to L di by dt. Now suppose I increase the current by suppose say k times. Okay. So what I will get, V is equal to, next, V is equal to nothing but L d, oh sorry, something was there. So what you will get, V is equal to L dk I by dt. Okay. It is very clear. Now you again know the principle of differentiation. You can take out this constant outside. So what you will get? Now you will get like this. L A D I, sorry, it goes, the problem is there. So it is very clear that it will obey the principle of homogeneity also. Okay. So inductor, the ideal inductor which we will be using in our electrical engineering, is also a linear element. So my next question is, what you will say about the, what you will say about your capacitor, whether it is a linear or non-linear. Once again, I am giving you some few minutes to answer. So same people are saying linear, 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 but you are giving the equal Q is equal to CV. So I am talking about the voltage and current relationship. Whether from voltage and current relationship, are they linear? Very few people are responding. Prakash saying linear, Q is equal to CV. Okay, okay. Very few people are responding. Others are either not active or they are not understanding the concept, because I should get answer from all people that what is about, what you will say about the linearity. Okay. So the capacitor is also the following the principle of linearity. How? Let us check it again. The formula is very clear. Let us start. Now you know that V is in case of capacitor, I is equal to, is given as C dV by dt. Is it clear? So now again you can apply the same principle. Say apply voltage V1. Okay, you will get current I1. Now you apply a voltage V2, current getting I2. Now you apply a voltage V1 plus V2. So what you will get? You will get C d1 d V1 plus V2 upon dt. When you open the bracket, you will get I is equal to, let it be I3. Okay, so I3 will be equal to C d V1 by dt. Okay, plus C d V2 by dt. Now this term is nothing but your what? V1, and this term is nothing but your, sorry, this term is nothing but your sorry, it is not, it is there, it is your I1. So this is your I1 and this is your I2. Okay, so we got that I3 is equal to nothing but I1 plus I2. Similarly, you can verify the homogeneity principle. So from there, it is very clear that uh, ideal capacitor is also a linear element. Okay, so from now onwards, whatever the analysis we will be going for the circuit in the circuit theory, we will assume the resistor, inductor, and capacitor. Okay, they are all linear, assuming it to be an ideal one. Okay, so from now onwards, we will not take into account that we will not ask whether it is a linear or non-linear. If nothing is written, we will assume that it is a linear element. Okay, so mathematically, I have given you that how to say this, whether it is a linear or non-linear element. Now comes the some more terms related to the electrical network. Okay, so previously we were talking about the some elements, about the elements, unilateral, bilateral. Okay, we were talking about the linear element, non-linear element, active element, no, sorry, passive element. Then we are also talking about lumped parameters and distributed parameters. We have also talked about the type of sources. Independent, there are only two, voltage and current, while dependent, there are four types of voltage and current sources are there. Okay, now when a network is formed, when an electrical circuit is formed, okay, some uh, terms come before you. Okay, you have to understand all this term. The very first term is the node. Okay, what is the node is there first of all? Okay, a node is nothing but it is in fact a junction. Okay, junction means where two or more than 2 points meet. Okay, we have in railway system, you might have heard the name like Marwar Junction, okay, Ajmer Junction, like this. So what is basically happening at these junction points? Okay, actually, where the trains are coming from two different rail lines and they are meeting at a point. Okay, so here also in an electrical network, okay, when any two elements, when two or more than two elements basically are connected at a common point, then a node is formed. Okay, now there are words like junction. In principle, okay, node and junctions are being considered as an synonymous terms. Okay, but mind it, junction and node are something different. Okay, in node we have to take into account not elements, though I have written it element, let me correct myself. Okay, it is not element, it is in fact branch. Okay, so I will correct it in my in the PPT. Okay, so node is a junction where two or more than two branches meet. I will later explain you what is a branch is there. Okay, so at present you can understand that where two branches meet. But what is a junction? A junction is a place where two or more than two elements connect together. So there is a difference is between, in general, you will find that in many books, you will find they will say both are same term. But mind it, node is somewhat more technical in the sense where two or more than two branches meet, while junction is a point where two or more than two elements meets. Okay, resistor and capacitor like they are there. Okay, it is a junction is formed. Okay, but if they are connected in series, okay, then they will be not be considered as a, will not consider as a node. If they are connected in series, okay, we will consider them as an consider as a branch. Okay, so because this is very important concept, later on you will see that we will be using a method called nodal analysis. It is not called as a junction analysis. Okay, it is called as a nodal analysis. So you have to be very clear in this point of view that what is a node and what is a junction. At a superficial level, it seems both are same thing, but they are not same thing. Okay, slight difference is there. In junction, two elements, two or more than two elements are connected, while in node, two or more than two branches are connected. Okay, now what is a branch? So branch is nothing but where elements are connected in series. Okay, so a branch is formed just as you have branch in a tree. Okay, some branches emerges out from the stem of a tree. Similarly, in a circuit, when one or more than two elements are connected in series, then they form a branch. Now, after the, so I will explain all these things with the help of a diagram. Okay, but before, let's go through its theoretical definition. Then there are another word called loop and mesh. Okay, so when a network is formed, we have many closed paths formed by different branches, okay, through which the current flows. Okay, so any closed path may be termed as a loop, While what is a mesh? A mesh is a closed path which does not contain any another loop. Mind it, the difference, that though in books it will be written that both are the same things, but both are not same things. There is a difference is there. Loop means any closed path consisting of the branches of the circuit through which current can flow. Okay, while what is a mesh? Mesh is a loop which does not contain any another loop inside it. A loop may contain another loop inside it, but a mesh is an independent itself, that is, it does not contain any other loop inside it. So later on, there is a method called mesh analysis where you have to identify mesh, not the loop. So that is what we call as a mesh analysis rather than the loop analysis. To understand this, I will draw a circuit, okay, to explain this. Sorry. So let us take a circuit. Now, this is a circuit where you can see there is a voltage source is there with a plus and minus sign. Sorry. There is a voltage source is there with plus and minus sign, and these are the some resistor which are connected in series and parallel and another configuration. Okay. Now, see this. What we will call this? Here, a voltage source and a resistor is meeting. Okay. So, what we will call this? This is a junction. Mind it, because these two connected are in series. We cannot call it as a node. Okay. Because they are connected in series. So, it is a branch. So, this is a completely a branch is there, but two elements are meeting, so it is a junction. But we have to again this. Now see this. What is this? This is again also a junction, but not node. Okay, where node is there? Now see, look towards this. Here, this branch is coming. This another branch is coming. Okay, and this branch is coming. So three branches are meeting at a point. So this is your node, mind it. Okay, now another identifier. Now take this point. This branch is coming, this whole branch is coming at this point, and this branch is coming. So again, this is another node. So there are two nodes are there. However, 1, 2, 3, there are three junctions are there. But mind it, in our so-called method called nodal analysis, you have to identify node, not junction. Now this is one branch, this is second branch, this is a third branch, because more than two elements are being connected in a series form. Then come the loop. Okay, so now looks toward the same circuit. Okay, find out the closed path. Let us start from there. Okay, so I am moving from here. Okay, moving from here. Okay, moving, going through this resistor, very fine, going through this resistor, and coming to the same point. So what is the closed path? Where the beginning points and end points meet together. So I have started from here, okay, and ends here. So closed path is formed. So this is my one such loop. Okay, very good. Now let us start from here. Okay, this is the beginning point. Okay, moving like this, moving like this, moving like this. Again I am moving like this, again I am moving like this, again I am moving like this, again I am moving like this. Okay, my beginning point and end point are meeting. So again a closed path is formed. This is my another loop. Okay, so now is there any more loop? Is there any more loop? Yes, there is any more loop is there. Let us start from here only. Okay. Now one more thing. While making a closed path, no element is traced twice during that closed path tracing. Okay. If you are tracing a closed path, no element is encountered twice. कोई भी एलिमेंट दो बार उस पाथ में नहीं आना चाहिए, तभी वो लूप या मैश कहलाएगा. अगर दो बार से ज्यादा आ गया, then it will be not be considered. Let us start with another loop. Okay, I am starting from here. Okay, going like this, 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 going like this. Okay, I am going like this. Now you see in this particular closed path, no element is traced twice, going like this, going like this, going like this. Okay, I have reached to the beginning point. So end point and beginning point as well. So you will surprised to know that this is also a loop. Okay, now what is the beauty of this loop? The beauty of this loop is that this contains this loop as well as this loop. So this is the third loop. One contains loop 1 as well as loop 2. Hence, loop 1 is a mesh also, loop 2 is a mesh also, but loop 3rd is not a mesh. It is simply a loop. So from this example, it is very clear what is difference between loop and mesh. Okay, so I am stopping here today. Tomorrow we will take some more question. Before this, I give chance to you to ask a doubt. If you have any doubt related to the content I have given today. Yes, please write in your chat box very fast. Yes, please write your question. Okay, Hardik Singh has asked, may be considered junction or node during counting of branch? May we consider junction or node during counting of branch? What I got from a question that you are asking that when to consider junction and when to consider. In fact, later on you will come to know about that a method called nodal analysis. So you were very much interested in the nodes. Okay, so node means where two or more than two branches meet. Okay, two or more than two branches, and a branch, in fact, if three elements are connected in series, okay, then they may have a junction, but they will be considered as a single branch. Yes, Meena Vikas, it is very correct. You have got it. There are three loops and only two mesh. Yes, in the question, in the example which I have cited on your screen, there is a yes, yes. Then the chat is going on. Please stop chatting. Ritika Panchal, please mute yourself. Yes, there's another question. Can we call voltage and resistor connection point a junction? If they are connected in a, yes, it is a junction only, but it will be considered as a branch. You cannot consider. Okay, so now I think so the no problem is there. So I am ending the meeting. Okay, there are very few participants were there. This is really a serious matter. So kindly tell your friends also to join these classes. We are making full efforts to provide you the content. So be sincere. Okay, I am ending the meeting. Thank you very much.